And now we need to go into finishing up the code that we on this file. So we were creating an object and setting its position. And next is let's mess with the scale. So you saw me making these shapes, these like irregular shapes that are squished or pulled, or and it kind of makes a fun pattern. So besides messing with the position, we can go back to the game object we're referencing, get its transform component, and go into the property of scale, and it's vector 3. And so, yes, it's local scale. But remember I was talking about how you can make game objects nest or be parented under others, and it's for organization purposes, but they also inherit the transform of the parent, so they inherit the motion of it. And that's going to be really useful. We'll see that in a bit with the UI. But just by convention, we manipulate the scale at the local space, which is whatever layer in you are, but it's just a quick note. So local scale is a vector 3, and by convention, an object usually has a scale of 111, meaning 100%. Whatever it's set to, that's the default scale. So if I create a sphere, it's like a 1 unit sphere, like a 1 meter diameter sphere. And if you scale up, notice the numbers go up, and now we're at like 200% or 300%, 400%, and then we can go down and shrink it below 1, and eventually when it gets to 0, it just like it's 0, it disappears. You go negative, but it's like flipping it around. So for me anyway, I'm like, oh, I want to paint stuff maybe down to like 0.1 up to 1, the default. This is like my acceptable range. Just by playing with it. So it does receive a vector. So we create a new object of type vector 3. But I want to put some randomness into it. So let me pop over and just do it this way first. Now, I can introduce you to random.range. So random is a Unity class. And it allows you to do randomizing data, which is really useful for games. And range says, hey, if you give me a minimum and a maximum, I'll give you a number in between, floats, decimals. So if I say I want a random number with an equal chance between 0.1 and 1, and that's how I came up with 0.1 and 1 for my scaling number. And I'll have an equal chance of getting a decimal number in between it, and I'll store it out as a float. And then I'll go into the scale of my objects, transform, and give it a new vector 3 with this random number. So we should get spheres scaled between a tenth percent to 100% its size. And I'm actually, I think I'm moving back and forth. Yeah, I got my distance changed. Let me get rid of that. So as I move, we see that we're getting spheres ranged from basically 0.1 to 1 and everything in between. Now, that's cool, but I wanted to get irregular shapes. I wanted to squish and pull it. So what's happening is I'm only making one random number, whether it's like 0.2 or 0.3 or whatever, and X, Y, and Z gets each get that same number. So we're always getting these like uniform spheres, perfect spheres. But what if I want to make this like different scalings on different dimensions? Well, I need a different X, a different Y, and a different Z. So let's create a new object of vector 3. And let's range each one. So it's like this is the X, this is the Y, and this is the Z. Right? So X will get a fresh random number between this range, same for Y, and same for Z. And now when I paint, I get objects of different scales. Let me turn off the distance change. Stop moving it back and forth through right now. But here you can see I'm getting like many different shapes and sizes. And that's because I'm randomizing each 3 numbers. All right. So next up, take the game object we just created, and let's go now. We were messing with the position and the scale. So let's mess with the color of it. So the color, the material of it, will be under this component, Mesh Renderer. And what I want to get to is I want to get down into the material. So this is the material that's in charge of coloring it. You can see that there's one material right now, though you can have many. Usually one is normal. And it's also shown down here. So this actually isn't a component. This is like showing what materials on the object. It's just a shortcut way to look into it. So let's first create a material and talk about what a material is. So I'm going to, it's an asset, an external file. I'm just going to create a material. And this is like fall 1 p.m. And it creates a standard material. It just creates like a default of the most commonly used type of shader. So a shader is code that runs on the GPU. So all your traditional programming languages, Java and C++ and C#, they're all running on the CPU. And it's a general programming languages for general computing tasks. Now, shaders run on the GPU, the graphics card. And it's a different piece of hardware, and so it requires a different language to interact with it. Shader languages are similar to C, and we're not going to dive into them. Just know that a bunch of shaders already exist that we can start with, and we're just going to use the standard shader. Now, what we really have here is a material. So a material you can think of as a wrapper. It wraps around a shader. A shader is too complicated. We need it abstracted away from us. And it exposes, it's like an interface for the shader. It exposes all the public properties you can think of. And you can tweak it to get your heart's content. So for example, albedo just means the base color. This is the main color that the object receives. You see I changed it red. And this like preview window shows what this object looks like. Some of the other things is this is like metallicness. This tries to make it appear more metallic or not. And this is smoothness. So like how much of a reflection, how much of a specular highlight there is. So with no smoothness, it's like a matte ball, like a rubber ball. And with high smoothness, it's like a polished glass, like a mirror, like a plastic with a high sheen on it. Okay, and there's other things you can tweak, a whole bunch of stuff. We're not really going to get into it. So we will be creating material and interactive materials, and just think of them as like an interface, an easy way to manipulate shaders, which we will not be getting involved with. So I'm going to take this shader I just made, and I'm going to drag it onto this object here. And notice now that the material is different here, and underneath the mesh render, the material that we're using is different. It's referencing this new one I created. And we can open it up, and we can do what we want. We can change colors on it, and make it different characteristics. So how do we do this with code? Well, that's what this line of code is doing here. And what's happening is we want to grab the game object. We want to go down and grab the mesh render component. We want to go down and grab this primary material. And go down that and go down into this albedo or color channel, or field or property. And we want to change it. So this is what's called a color wheel. And here we have RGBA. So red, green, blue, alpha. All right, you could think of just mixing color with different amounts of a red, green, and blue. So if I like pump red all the way up and take out green and blue, we have red. If I pump green up and pull out the red, we have green, and so on with blue. And you could just make varying mixtures with varying amounts of red, green, blue. So we go from 0 to 1. Basically, 0 means 0%, 1 means 100% of that color. So the colors that we'll be interacting with will be a vector 4 with floats, 4 floats, and we set them between 0 and 1. And I'll cover alpha later. Now, red, green, blue, behind the scenes, is really mapping to 0 to 255, or 256 shades of each, of red, of green, of blue, and alpha. So 2 to the 8 are 8 bits, 8 zeros and ones, 8 bits in binary. You can make 256 combinations. So that can represent 256 shades of red and green and blue. And so that means we have 8 bits to represent red, and 8 bits for green, 8 bits for blue. And that's where we have 8 times 4. We have 32-bit color. All right, and so we've gone through generations of computer graphics. You may have heard of 8-bit or 16-bit, but we're currently at 32 bits of color. It is enough color for the human eye. So we don't need to know behind the scenes that, but we can just work with numbers between 0 and 1. Now, another way to look at the color values, just so you get a full lesson on it, is hue, saturation, and value. And these, you can use these numbers or you can use the other numbers. We'll be using red, green, blue. But notice as I move over here, we're changing the hue. The hue is like the type of color, the hue of color. And notice as I move in here, left to right, we're just changing saturation, how saturated the color is. And as I move up and down, notice I'm just moving V, that's value. So the value is like how illuminated the surface is, how much value of the light source is on it. So normally you kind of want it right around here is like what's known as like web safe colors, or just so you know when you pick color palettes, usually around here. And that's what this values, and that's why this graphic, this color wheel looks like this. But we'll be using RGB and A. So as I tweak A, notice it doesn't do anything, all right? So for that, I'm gonna have to go back to our material. Let me just get rid of this metallicness and smoothness, dim it down so it's easier to see. By default, the rendering mode is opaque. And the reason for that is that opaque is cheap to render. It's just a bunch of opaque objects. You can't see through them. They lay on top of each other. Transparent objects are more expensive. That's why you have to purposefully set to it. And now when I lower the alpha, notice the object is like disappearing. Now it doesn't completely disappear because it is a standard. It's got this like specularity to it. The light source is hitting it, and we can't get rid of this specularity entirely. So it's like an invisible object that has like a reflection on it, kind of like a glass ball or something. But if we switch to another shader that didn't have that specularity, it would disappear altogether. So that is A for alpha. All right. So now that we understand color and the color wheel, how do we get down to changing it? So grab the reference to the game object, dot, call a member, call a method on that game object, and that method's going to be called getComponent. And what type of component do you wish to try and get? And here we have smooth braces because this ends up being a method call. And the type of object, the type of component object that we're trying to find is within these angle brackets. So these are what are known as generics. So if you come up top here, notice you have systems collection and collection.generics. So they are a popular programming technique. Here it's used because get component is a method, and it's saying, hey, get me a component object on this game object. It's saying, okay, which one? And then you have to specify the type, which one. But there can be many types. In addition to being many types, there can be many unknown types, because developers can create their own classes, such as what I did, and make it a component object. So you basically have like an infinite number of components to search for type-wise. And so generics are a way to help in this type of situation. It's like, yeah, you could create methods that are overloaded, that have like receive many different types of input parameters, and based on the input parameter, do different type of like logic. But what if you don't even know what the input's gonna be? Or there's just too many to keep writing it out. So you make it a generic, means it'll receive a generic type. And then within the logic, you like handle that generic type. That's as far as you need to know, just angle brackets, in this case, generics, and why it exists. So you can actually throw in the transform there too. You say, hey, get component of type transform. It's just that the transform is referenced so much and it's required, so there's like a little shorthand way to get to it. But any of these components here, the renderer, the collider, this filter, even my own scripts like these, you could search for and try to find. Now what happens is you're saying, go call this method on the game object. The game object says, okay, I'm aware of my component objects. There's a collection of them. I'm going to move through them and see if I can find whatever it is that you're looking for. In this case, the mesh render. Now, it can either return back a reference of that object type, in this case, a mesh render, or it can return back null, saying, I didn't even find anything. It depends if it exists or not. You don't know. But in this case, since I'm creating these primitives from Unity, I know that there will be a mesh render and this will never be null. So this will return back a reference, a variable reference, a reference of type mesh render, which is this component. And then I want to go down into the materials and grab the first one. And then when I grab that material, I want to go into its color, also called albedo. So that's why it's, okay, when we got the mesh renderer, go to its material property. And then when you have that object, go into its color property, which is of type color. But the color class and the vector4 class are like almost interchangeable. A color is just a vector4 with just a few different other capabilities, but you can just pass in a vector4 and it'll be received as color that's similar. So that's why it says new vector4, and the vector4 is going to have red, green, blue, and yellow. So give me a random range from 0 to 1 for red. Give me a equal chance of any type amount of red, equal type amount of green, and blue, and alpha as well. So when I run this, that's why when we paint, we get all the different colors. Now notice that they're opaque. Even though they're getting random amounts of alpha, the default material, because we're creating primitives directly from Unity, the default material is cheap and it's opaque and doesn't accept changes in alpha. But later, when we make our own prefabs and our own fun painted objects, we will create our own materials and assign it to them. Then we'll be able to change the alpha. Cool. So I'm going to stop there. And I'm going to start again unless there's any questions. Nope. Cool. Where's my recording?